About that, I had a quick distraction. Back to our lesson. We are looking at what happens when you take an inverse function and put it into its original function to simplify down to x. And we're talking about how this only works as if x is in the domain of its inverse function. And remember, the domain for tangent inverse is negative infinity to positive infinity. So this works for everything, every x value for tangent. These little f of f inverse of x simplifies down to x. It also simplifies down to x if you were to reverse it. So now we're talking about f inverse of f of x, meaning that we're going to take the original function and put it inside of its inverse. As long as they're inverses of one another, they also simplify down to x, but this time it's as long as x is in the range of sine inverse. Remember, the range of sine inverse is negative pi over 2 to pi over 2. So it only works from negative pi over 2 to pi over 2. Cosine inverse of cosine of x. So if I take cosine of x and stick it inside of the inverse cosine function, I get just x as long as x is in the range of cosine inverse. And the range of cosine inverse is 0 to pi, right? Because I have the sine function. I'm looking at these values over here. For cosine, I'm looking at these values here, quadrant 1 and quadrant 2. That's the little picture that we drew in class. And then tangent inverse of tangent of x simplifies down to x as long as x is in the range of tangent inverse. And the range of tangent inverse is negative pi over 2 to pi over 2. And we're not including the pi's over 2's because they would give me an undefined value. So while sine includes these endpoints, tangent is looking at the same ones but not including those values, because that's where tangent is undefined. Okay, let's look at some examples. Here I have the cosine of the cosine inverse of root 3 over 2. Now, according to our rules, if I have cosine of cosine inverse, it should be whatever this value is, x, as long as x is in the domain. So is root 3 over 2 in the domain of cosine inverse? Sure it is. So this answer is just root 3 over 2. Over here, I have sine of sine inverse of 1.8. Is 1.8 in the domain of sine inverse? No, it is not. Remember, the domain is negative 1 to 1. So therefore, this, if I was to try to do this by hand and try to find sine inverse of 1.8 first in my calculator, I would get what's called a domain error. And this answer does not exist because I'm not able to find the sine inverse of 1.8. The sine inverse of 1.8 is just saying, hey, there is an angle where if I take the sine of the angle, I get 1.8. Well, if this is true, that means I would have a right triangle. If this was angle theta, that means that the opposite would be 1.8 and the hypotenuse would be 1. There's no way for the hypotenuse to be smaller than the leg, and that's why I am not able to do this. This is undefined. It looks like that. It's called the empty set. You can't do that, so it does not exist. Okay. Let's look at the reverse. So now I have a tangent function inside of my tangent inverse. So remember the tangent of pi over 6 inside of my tangent inverse. If this is in the range of tangent inverse, so the range of tangent inverse is negative pi over 2 to pi over 2. And since pi over 6 is in between here, this answer is just pi over 6. On this side, the sine inverse of the sine of 3 pi over 4, well, this answer will be 3 pi over 4 if and only if 3 pi over 4 is in the range of sine inverse. Remember, the range of sine inverse is negative pi over 2 to pi over 2. 3 pi over 4 is not in the range, so I have to do this by hand. So I'm going to take this step by step, and when you're doing composite functions, you want to do the inside first. So the sine of 3 pi over 4 is root 2 over 2. So therefore, this question is asking what is the sine inverse of root 2 over 2. And the sine inverse of root 2 over 2 is 45 degrees, or pi over 4, however you would like to answer that in radians or degrees. Because when the outside is an inverse function, my answer is an angle. When my outside is a regular function, my answer is a ratio of side lengths. So let's show that. If I have trig, and then a trig inverse of, this will be a ratio. All right, so this is going to equal a ratio. That's because what this represents an angle. So it's asking for ultimately some trig value function of an angle equals a ratio. But if I reversed it, the trig inverse of a trig with an angle inside is going to give me an angle. And that's because this thing right here represents a ratio of side lengths. So this is really asking for the trig inverse of a ratio, and that equals an angle. Okay. Let's look at a couple more examples together. If I am not putting, so here I have the sine of tangent inverse. So I'm not putting, now I can't use any shortcuts because I don't have sine inverse inside of a sine. So now I have to do this the long way, which is just taking it piece by piece. So I'm going to do the inside first. So the tangent inverse of -1. The tangent inverse of -1 is going to be negative pi over 4. So what is the sine of negative pi over 4? And that is negative root 2 over 2. Now, if you're asking how I'm getting these values, I know the unit circle. You have to know the unit circle or have the unit circle in front of you at all times, right? Where is tangent -1? Well, I know that tangent is 1 at 45 degrees. So that means that it's -1 at negative 45 degrees, which is negative pi over 4. That's how I got that negative pi over 4 value. Okay, gotta know your unit circle. And then here, again, I would look at this and say, okay, let's do the inside first. The sine of pi over 2. Pi over 2 is right here. The sine value is 1. So this is looking for the cosine inverse of 1. So where is the cosine value positive 1? It's going to be at this point right here, which is at 0 degrees or 0 radians, whatever you want to call it. Okay, so I'm just doing the inside and then the outside. So basically, I'm doing two problems in one when I'm doing a composite function. And last but not least, remember arc cotan, if I put arc in front of it, is the same thing as saying cotangent inverse. They mean the exact same thing. Okay, arc just means inverse. So this is asking for the sine of the cotangent inverse of x over 2. This right here, this represents an angle that we'll call theta. Okay, and what this is saying is that the cotangent of some angle theta is equal to x over 2. Our answer is going to be an expression, meaning x is going to be in our answer, and that's okay. If I was to draw a triangle to represent the inside of my trig function, my triangle would look like this. Here's a triangle. Here's angle theta, this angle right here. And cotangent is adjacent over opposite, so x and 2. And I can find a third missing side by doing the Pythagorean theorem, which says x squared plus 2 squared equals, we'll call this side c. So c squared. So therefore, if I take the square root of both sides, I get the square root of x squared plus 4 is equal to c. So this missing side is the square root of x squared plus 4. Now, this question wants me to find the sine of this angle. Well, I created a triangle with the angle in it. So the sine of this angle, the sine is opposite over hypotenuse. So therefore, the sine of angle theta, which is really the arc cotangent of x over 2, is the opposite 2 over the hypotenuse, the square root of x squared plus 4. And because I don't like this radical in my denominator, I'm going to rationalize it by multiplying the top and the bottom by x squared plus 4 to give me 2 square root of x squared plus 4 over x squared plus 4. And this is the expression that represents the sine of this angle that's created by x and 2. This triangle has an angle in it, and I drew this triangle from this information right here. So why is this important? Well, if I wanted to input any value of x into here, if I want to put a 5, that means that I would just put 5s into these two x's, and I would get the sine of the angle that's created. So my answer was an expression, and that's okay. I want it to be an expression. We'll do some more practice in class. I'll see you all soon.